Welcome to the presentation on I and imaginary numbers. So let me just start out with a definition. I is equal to the square root of negative 1. Or to view it another way, you could say that I squared is equal to negative 1. Now why is this special? Well, we knew that, or we've learned, that any number, when you square it, is equal to a positive number, right? If I had negative 1 times negative 1, that equals positive 1. You don't have to write the positive every time, but that equals positive 1. And so does 1 times 1. That equals positive 1. So if we think about the square root of a number, so far all we've learned is taking the square roots of positive numbers. And that makes sense to us because the notion of a square root of a negative number didn't really exist until now. So what we've done is, if we've set this definition that the number I, and I isn't a variable, it's an actual number, its value is equal to the square root of negative 1. Now I won't go into all of the philosophical musings about whether the number I, or any imaginary numbers actually exist. I mean, maybe I'll make another presentation on that, but they exist enough to be very useful to many engineers and physicists. So I'll leave you with that, and I'll also I'll just hint at well, I won't go into the whole e to the I pi equals negative 1, but that blows my mind, but I won't go to that. And when you think about whether I really exists, you should also think about whether anything really exists. Well, anyway, so I've diverged for too long. So let's get back to what I was saying before. I is equal to the square root of negative 1, and I squared equals negative 1. So let's think about the implications of this. If I were to say, well, I to the first power, just like anything else, is equal to itself, right? I squared, I've already said, using this definition, I squared is equal to negative 1. I to the third power, well, that would just equal I squared times I, right? And I squared is negative 1, so it would be negative 1 times I, and that just equals negative I, right? And I to the fourth would equal I to the third times I. Right? I'm just using my exponent rules here. Well, I to the third is negative I times I, right? I to the third is negative I, and then we just kept that I. Well, what's negative I times I? Well, that's the same thing as negative 1 times I, right? And what's I times I? Well, definition. I times I squared, is equal to negative 1. So that equals negative 1 times negative 1, which equals 1. Interesting. Let me clean this up a little bit. So actually, let me start with I to the 0th power. I to the 0th power, well, we know anything to the 0th power is equal to 1. So we'll keep that. That still equals 1. I to the first power is equal to I. I squared, by definition, is equal to negative 1. I to the third power, I just showed you, is equal to negative I. And that makes sense because that's just I squared times I. And I to the fourth power equaled 1 again. And if I did I to the fifth power, well, that's just equal to I to the fourth power times I, right? I'll write that down. I to the fourth times I. That's a times. I to the fourth is equal to 1, right? This is equal to 1. So 1 times I is equal to I. Do you see a pattern here? I to the 0th power equals 1. I to the negative 1 power equals I. I to the squared power, I squared equals negative 1. I to the third power equals negative I. I to the fourth equals 1 again. So I to the fourth equals I to the 0. And I to the 1 power is equal to I to the fifth. I think you'll find out that I to the 0, and you could try this out if you don't believe me. I to the 0 is equal to I to the fourth, which equals I to the 8th, which equals I to the 12th. I think you see the pattern. Any multiple of 4 equals 1. And I to the first equals I to the fifth equals I to the ninth equals I to the 13th equals I. So that's I to any power that is a multiple of 4 plus 1, right? Because 5 is equal to 4 plus 1, 9 is equal to 8 plus 1. And we could do a similar pattern. I squared is equal to I to the 6th, is equal to I to the 10th, and so on. And that equals negative 1. And finally, I to the 3rd is equal to I to the 7th, which equals I to the 11th, and so on, equals negative I. So why is this useful? We see a pattern. It's a cycle of 4. And so in this pattern, if we look at this, we can use this to determine what I to any power is. So if I were to ask you what I to the 100th power is, well, you could just work it out. You could say, well, that's just equal to I times I to the 99th, and so far so down. But if we use this cycle, we see that 100 is a multiple of 4, right? 4 times 25 is 100. So I to the 100th will fall into this category, this first one. It's a multiple of 4. So we know that I to the 100th power is equal to 1. Similarly, if I said I to the 101 power, that's going to equal I, right? Because that equals 100 plus 1. So it puts you into this category. It equals a multiple of 4. 100 is a multiple of 4. And 101 is a multiple of 4 plus 1. I to the 102nd power, similarly, would equal negative 1. I to the 103rd power would equal negative I. I hope you understand what I'm doing here. And all I did is I defined I as the square root of negative 1. And then I kept multiplying I to figure out a pattern. I said I to the 0 equals 1. I to the first equals I squared equals negative 1. I to the third equals negative I. And then I to the fourth equaled 1 again. And then the pattern repeated itself. And then I used that pattern to be able to figure out I to any power, even if it's a very high number. So a very simple way to think about it is, if I had I to the 323, what I do is I say, well, if I were to divide 4 into 323, what's the remainder? Well, I know 4 goes into 320, right? 4 times 80 is 320. So I know that when I divide 4 into 323, so 4 goes into 323 80 times with a remainder of 3, right? And the remainder is what we care about. And this number is actually called the modulus. And maybe I'll do another module on modulus. It's very important in computer programming. But since we know that when you divide this exponent by 4, the remainder is 3, we can say that this is the same thing as I to the third, which we've learned is negative I. Similarly, if I said I to the 500th and second power, well, I know 500 is divisible by 4, right? 4 times 125 is 500. So the remainder is 2 if I were to divide it by 4. So I could say that this is the same thing as I squared. And I squared, we learned by definition, is negative 1. If I were to ask you I to the 37, we know 36 is divisible by 4. So the remainder is 1. So it would be I to the 1, which equals I. Hopefully that gives you an indication of what I is. It might have been confusing the first time because we're dealing with a number that's quote-unquote imaginary, and I'm teaching you the cycle property of it. What you might want to do is review the video again, but then after that you could just try the module on I, which essentially just keeps working you through this type of problem. I hope you have fun. Bye.